Welcome to this explainer. All right, let's just jump right into this. I want you to take a little trip with me into the future, specifically the year 2045. Imagine a world where the ultimate fight for global supremacy, it's not about borders anymore, and it's sure not about oil. It is about the single most vital resource for human survival, water. We're diving into a fascinating future history scenario today, unpacking this concept known as the HydroVerse. It's a world where artificial intelligence, next-gen military tech, and hyper-smart infrastructure literally decide the fate of nations. Now, to understand exactly how we get to 2045, we actually have to look at the megatrends unfolding around us right now. Global freshwater shortages, accelerating climate change, population explosions, and these severe, unending droughts, well, they aren't just ecological issues anymore. They've fundamentally transformed water into the ultimate strategic military asset. In this highly contested future, securing water equals survival. And the interconnected systems built to protect and distribute it, that is exactly what strategists are calling the HydroVerse. Chapter 1. The Water Wars of 2045. So, looking at this future landscape, global conflict has entirely shifted, which brings us to a really critical question, right? How do nations actually achieve water independence on a global battlefield? Well, the answer lies in a heavy-duty military water tech. We're talking massive portable desalination systems, atmospheric water generators, and mobile reverse osmosis units dropped directly into combat zones. But, here's the catch, and it's a big one. These life-saving water purification megaprojects require an absolutely massive, uninterrupted supply of power to even function.
Chapter 2. Powering the HydroVerse with SMRs.
To get that kind of massive, zero downtime power, we have to look at the foundational solution. The sheer dominance of nuclear energy when it comes to reliability it's unmatched. Nuclear power achieves a staggering 93% capacity factor. It is completely weather independent, and it runs 24/7. When you compare that to wind or solar, which typically sit down in the 20 to 30% range, it becomes incredibly clear that renewables just aren't going to cut it for military-grade water purification. You need extreme, unshakable reliability, and that is exactly what small modular reactors, or SMRs, bring to the table. And the scale of this transition, it is breathtaking. Industry research is pointing to a 700 gigawatt transformation by 2050. By moving away from those massive custom-built decade-long nuclear projects and transitioning toward mass manufacturing, where reactors are just built on assembly lines and shipped directly to the site, SMRs unlock the ability to power enormous industrial and military water needs efficiently. This is quite literally a trillion-dollar shift that makes the entire HydroVerse possible. Chapter 3. The Drone Asymmetry Threat. But here's the thing. Having a brilliant SMR-powered water fortress is really only half the equation, right? Because you have to protect it. Let's pivot to the major vulnerability of these installations, the sky right above them. We have to break down the terrifying economics of modern warfare. On one side of the equation, you have offensive loitering munitions, like the Shahed 136 drone, built with cheap, commercial off-the-shelf parts. They cost roughly $20,000 to $50,000 to produce. But on the defensive side, intercepting that cheap drone with a traditional military-grade system, like the Iron Dome's Tamir missile, well, you're looking at between $40,000 and $100,000 per shot.
So this brings us to a crucial concept that military economists call the cost exchange ratio, or CER. Basically, if your CER is greater than 1, you're losing the economic war. In the drone versus missile scenario we just looked at, the ratio sits at an average of 3.3 to 1. This means the defender is just systematically bleeding money. When an attacker launches a saturation attack, basically a massive swarm of cheap drones, the defender quickly hits a financial saturation point. Protecting your water infrastructure with traditional missiles, it literally bankrupts you over time.
Chapter 4. Iron Beam, Reversing the Cost. To survive these water wars, nations can't just play defense. They have to flip the economic script entirely. Enter directed energy weapons. $10. Seriously, let that sink in for a second. The estimated cost of a single shot from a high-energy laser system like the Iron Beam is between $2 and $10. This is an absolute aha moment for the future of defense. This asymmetric defense shift is an absolute game-changer. Think about it. If an incoming drone costs $30,000 and your laser defense shot costs $10, your new cost exchange ratio plummets to 0.00033. The economic advantage completely shifts back to the defender.
You effectively neutralize the whole drone swarm strategy because as long as your SMRs keep pumping out reliable power, your lasers have an infinite magazine of ammunition. It is a perfect closed-loop defensive ecosystem.
Chapter 5: Digital Twins and Cyber Defense. Okay, but kinetic attacks from the sky? That's only half the battle. The other half is totally invisible. Protecting the HydroVerse requires incredibly advanced AI and cyber defense to safeguard against digital sabotage. And hey, this isn't just theory. Take Valencia, Spain, for example, managed by Global Omnium. They use what's known as a digital twin. It's essentially a highly accurate virtual replica of the city's entire drinking water network. By simulating the physical system perfectly in a digital space, it functions as an unparalleled cyber fortress and an operational brain. The mechanics behind this are just staggering. The AI is continuously ingesting data from over 10,000 smart sensors, measuring pH, pressure, chemical content, the whole shebang. The digital twin synchronizes with the real, physical water system every 30 to 60 seconds. So you have these machine learning algorithms analyzing all this historical and real-time data to predict leaks, detect contamination, and instantly flag cyber anomalies if values deviate from safe thresholds. It literally acts before a major failure can even happen. And when you implement this kind of AI oversight, the tangible victories are huge. Using this digital twin technology resulted in a 30% reduction in non-revenue water. That's water lost to leaks or theft, by the way. They saved 15% on energy and treatment processes, dropped maintenance operating expenses by 20%, and physically saved 4 million cubic meters of water. I mean, this is exactly how you preserve the world's most vital resource. Chapter 6: The Smart Water Battlefield. So let's bring all of these incredible technologies together into a grand synthesis of our 2045 scenario. Paint this picture in your mind. It's the ultimate self-sustaining water fortress of the future. You've got operators sitting in a highly advanced central control room. Deep underground, small modular reactors are providing this immense, unshakable off-grid power. Above ground, $10 directed energy lasers are just swatting cheap drone swarms out of the sky with unlimited ammo. And inside the network, AI digital twins are constantly running microsecond simulations, fighting off cyber anomalies and optimizing every single drop of water. This is the HydroVerse. Which leads us with one final, deeply important thought to chew on today. We've traveled to 2045 for this explainer, but the technologies and the threats, well, they're already here. As global pressures mount and water becomes the ultimate strategic asset, you really have to ask yourself, is your local infrastructure ready for the HydroVerse? Thanks for joining me for this explainer, and keep questioning the future.